Welcome back to Algo.js. Today's question is LeetCode 253, meeting rooms 2. So given an array of meeting time intervals where interval I is equal to start I, end I, return the minimum number of conference rooms required. What the question is asking for here is how many overlaps are there at any point in time within the intervals. In the first example here, we have 0, 30, 5, 10, and 15, 20. Now, at any point in time, we have two meeting rooms, right? Because at any point in time, there is one overlap. So we have to have two conference rooms, okay? So 5 to 10 and 15 to 20 are found within 0 to 30. However, 5 to 10 is not interlinking or doesn't have an overlap with 15 to 20. So at most, there can be only two conference rooms. With the second example, 7, 10, 2, 4, there is only one conference room because there is no overlap within this meeting room. So as soon as we loop through this array, this conference room is open. So we have one conference room here. So let's have a rooms variable, which is going to store how many rooms are available at any point in time. So we have one. As soon as we reach this level, this one is still going to be open and we have started a new one. So at this point, we are going to have two rooms open. And then once we reach the end here, so once we reach this point, this conference room is going to close. So rooms essentially is going to go back to 1. Once we get to this point, another room is going to open up. So this is going to go back to 2 because remember here, we closed it. So it's going to be 1. And then here it's going to equal 1 again. So as you can see, the maximum amount of rooms that we need at any point in time is 2. And that is the output that we need to return. The difficulty in this question is kind of working out a way to check the initial values to see whether they're before the last values within these intervals. So we need to extract out the start values from this array, and we also need to extract out the end values and put them into separate arrays. So if we have start, which is equal to 0, 5, and 15, this also needs to be sorted. And we have end, which is equal to, well, we'll call it starts and ends, 10, 20, and 30. Now within this, we can easily compare the starts and the ends. So at any point, if start is less than end, we can increment rooms by 1. Okay, so we're going to have rooms and end. So initially rooms is going to be set at 0. We compare the start, which is 0 to 10. Is it less than 10? Yes, it is. So we can increment rooms to 1. We move to the next value in start, which is 5. That is also less than 10. So we can increment that pointer again to 2. Then we move along. Starts is equal to 15. 15 is greater than 10. So rather than incrementing rooms in this one, what we're going to do is we're going to update end, which is the index within ends. So this is going to be incremented by 1. So we're going to increase that to 1. So we move ends along. And then we'd carry on this until we exit one of these. And then we can just return the value of rooms. And there is just one small edge case that you need to take into consideration. And say we have 20 to 25 here. Okay, so we have an extra value onto these arrays. When we reach this point, this right here is considered one room closing whilst another one's opening. So this is not an overlap. So unlike merge intervals, where we have an endpoint which is equal to a start point, that is equal to an overlap. In this question, this does not equal an overlap. So we can just carry on as normal. So if we do this again, so we start at starts, this is less than 10, we increment room, we increment start. Start is 5, that's less than end, which is 10, so we increment room again. We move over to 15. 15 is now greater than 10, so we increment end, which is the index to end, to 1. So we can increment ends. We also need to increment starts here, and we can see 20 is equal to 20. That is not an overlap. So in this case, we are just going to increment end, not change start, and then we exit start. So we're now out of bounds, so we can just return 2. Time complexity for this one is going to be n log n, because initially with this array, we need to loop through or map the values, and then we need to sort them via their first or second values. So it's going to be n log n, and space complexity in this one is going to be O n plus m, where n is the length of starts and m is the length of ends array. Okay, so let's just cover an edge case. So if intervals is equal to null or intervals dot length is less than 1, we can return 0. Because there are no intervals within the array, there are no times for meetings, so essentially no rooms are needed. So firstly, we need to sort the intervals into all the start values and end values. So we can have comma starts. So we're going to map over the values. We're going to take in intervals or interval. And we're going to grab the first values within that, and then we're going to sort them in ascending order. And then we're going to do that for ends. And we're just going to take in and map over the second values within those arrays. So we're going to grab the ends. Let's create the 2 pointers. So rooms is equal to 0. End is equal to 0. We're going to loop over so that I equals 0. I is less than intervals.length I++. Now if starts at I is less than ends at end, we need to increment rooms, else we add to end. So every time a new room is opened, or every time a starting value is found that is less than the current ends, we increment rooms, else we're going to update the ends. So we're going to move to the next end value within the list. And finally, we can return rooms. I'll submit it. And there you go.